Hello class, today we are going over the practice test for Unit 2. So this is a practice test for our test 2 of Unit 2. Let's look at the first page. On page 13 of your handout or your packet, we had a page of definitions. This page will be exactly like the first page of your test, so you must learn these definitions. They're very simple. Let's look at the first one. The first one says, draw the correct circle, open or closed, for each inequality. As we know, if we have that extra line underneath our inequality, that means we're including the value. So therefore, we have a closed circle. Otherwise, we have an open circle. We should all know that by now. As well as number 2, we've worked a lot with flipping the inequality sign, so we should know by now that if we multiply or divide by a negative number, we must flip the inequality sign. Number 3 says compound inequalities can be written as a connected or joint statement. So remember, connected or joint statements are something that look like this. For example, -1 less or equal than 3x plus 1 less than 4, for example. This is what we call a connected or joint statement. We have our two inequality signs, but there is no connecting word in between. So remember, whenever we have a compound inequality, we must have either and or connecting the two statements. If there is no word given, such as in this example, that is an and statement. Number 4, it is enough in the test if you give me the second part of this definition. So the absolute value is the distance that number is from 0. And number 5, for number 5, we need to remember the acronym GOAL. G stands for greater than symbols, O stands for or, A stands for and, L stands for less than symbols. So now if we look at number 5, it's asking us absolute value inequalities that use greater than signs become or statements. And absolute value inequalities that use less than signs become and statements. So this is easy to remember by remembering the acronym. So now let's move on to actually solving the problems on the practice test. Remember, your actual test is very similar, so your practice test should be your study guide. Number 6, solve and graph the inequality. Here we have a simple one-step inequality. Remember, the goal is always to get x by itself. That means on the left side of my inequality, I need to have only x. Right now I have that 7 as well. So on both sides of the inequality, I will subtract the 7. 7 minus 7 goes away, gives me x greater than 3. At this point, I am done solving the inequality and I just have to graph. Here's my 0, here's my 3. I'll put an open circle around 3 because I have greater than. We don't have that extra line underneath. Greater than 3 is to the right, so all the numbers to the right of 3 are going to be greater than 3. Number 7, same idea, I need x by itself. So if I look on the left side of my inequality sign, I see I have a -4 that's extra and that -7 that I need to get rid of. So remember, you always get rid of your constant first. Okay, this is your constant. So I can go ahead and add a 7 on each side of my inequality. And I get -4x less or equal than -28. I still have that -4 there I need to get rid of. Because I have between -4 and x multiplication, I'll do the opposite, which is division. So I'm dividing both sides by -4. My -4 goes away, and I get x. And now just pay attention. Here you must flip the sign because we're dividing by a negative. So if I go back and look at my definition number 2, it says if I multiply or divide by a negative number, I must flip the inequality sign. So here I divided by a negative, so I must flip the inequality sign. So x greater or equal than -28 divided by -4 gives me a +7. At this point I am done. I just need to graph my inequality. So here's my number line, here's my 7. I'll put a closed circle on 7 because I have that extra equality sign underneath. So it's greater or equal to 7, so I'm including 7. All the numbers greater than 7 are to the right. Let's look at number 8. Number 8, I can solve this problem in 2 ways. So I'll show you both ways. Number 1, as many of you probably prefer to do, distribute the 3. So I get 3x minus 6 less than -12. Don't forget to distribute the 3 to the 2 as well. So 3 times x gives me 3x. 3 times 2 gives me 6. Now I need x by itself, so I need to add a 6 to get rid of that 6. And I get 3x less than -6. Next step, I need to get rid of 3, so I divide by 3 on both sides, and I get x less than -2. Don't forget here, I do not have to flip the inequality sign because I'm dividing by a +3. The second way in which you can solve this problem is divide both sides by 3 in order to get rid of that 3 instead of distributing it. Because between 3 and my parentheses I have multiplication, I do the opposite, which is division. I divide by 3 and I get x minus 2 less than -4. Now I can add a 2 on both sides to get rid of that 2 and get x by itself. So x is less than -2. So both methods give me the same result, x less than -2. And now the final step, I need to graph this inequality. So here's my number line, here's -2. Around -2, I'll put an open circle. X is less than -2, so my arrow goes to the left. All the numbers less than -2 are to the left of -2. Let's move on to problem number 9. And here we have a compound inequality, which means we have actually 2 inequalities into 1. Remember, whenever you have a compound inequality, you must have a connecting word. So that word is either and or. If I'm not given a connecting word, I am assuming the word is and. Again, that is your definition on the first page. So that's number 3. It says here if we have a connected or joined statement, the word we use is and. Here we have a connected or joined statement, so there is no connecting word. Therefore, we assume that word is and. Now that we found our word, we can move on to splitting this connected statement into 2 inequalities. In order to do this, I'll take my first inequality sign, which is less or equal than, and my second inequality sign, which is less than. Now I have to look what's on the left of my first inequality sign, which is -20. And then what is on the right side of that first inequality sign? And be careful here. When you look what's on the right side of the sign, make sure you read the whole expression until you reach that second inequality sign. So on the right of my first sign, I have 3x plus 1. Now let's look at the second inequality sign, less than. On the left side of it, I have 3x plus 1. And on the right side, I have 16. So now I'm done splitting my inequalities into two. If I look at the first one though, I see my x is on the right side of the inequality. I would prefer it on the left just because it's easier to solve. So let's flip this whole inequality over. Just flip it around and I get 3x plus 1 greater or equal to negative 20. So I just took that inequality and flipped it around just so my x's are on the left. And 3x plus 1 less than 16. So now everything looks good. I can go ahead and solve these just like I did in number 8 and number 7. So again, the goal is to get x by itself. So I need to get rid of 3 and of 1. I get rid of my constant first, so I subtract the 1 on both sides. My 1 goes away, and I have 3x greater or equal to negative 21. Now I get rid of 3 by dividing by 3, and I get x is greater or equal to negative 7. So I'm done solving that first one. Now let's look at the second one again. I need x by itself. So I'm getting rid of my constant first. Because I have addition, I'll do the inverse operation, which is subtraction. So 1 minus 1 gives me 0, cancels out, and I get 3x less than 15. Between 3 and x, I have multiplication. The opposite is division. So I divide by 3 on both sides, and I get x less than 5. Again, the word in between is and. And remember, and means intersection or overlap. You need to remember the definition of the word. So now let's move on to graphing this. So on a number line, I'm going to graph the first equation, the first inequality, x greater or equal than negative 7. So here's my negative 7. I'll put a closed circle around negative 7. Greater than means all the numbers to the right of negative 7. And now I can graph on the same number line the second inequality. The second one is x less than 5. So here's my 5. I put a open circle this time because I do not have that extra line underneath that shows me equality. X less than 5, this means all the numbers less than 5 are to the left of 5. And don't forget here, you still need that final answer, that final graph that shows me the solution for the compound. So again, and means intersection or overlap. So where do my two graphs overlap? Well, they overlap between negative 7, including negative 7, and positive 5, not including 5. So here in purple, you see the final solution to the graph. Let's move on to number 10. Number 10 is very similar to number 9. This time the problem gives you the word. The word is or. That connecting word is or. So I do not have to split it into two. It's already split. I can just go ahead and solve these independently. So if you look at the first inequality, I need x by itself like always. So I need to get rid of 3 and of 2. Well, which one do I get rid of first? Always get rid of your constant first. Because I have addition by 2, I'll do the opposite, which is subtracting a 2. The 2 goes away, and I have 3x less than 9. I still need x by itself, so I need to get rid of 3. Between 3 and x, I have multiplication. and I do the inverse of that operation, which is division. I divide by 3 and I get x is less than 3. So now I'm done solving that first inequality. I can move on to solving the second. Again, I need x by itself, so I first get rid of that 1 by adding a 1 on both sides. So I get 10x greater or equal to 50. Next, I get rid of 10 by dividing by 10 on both sides, and I get x is greater or equal to 5. I'm done solving all of them. The connecting word again is or. And I can move on to the last step, which is graphing. Don't forget, all of your problems in the test will say graph. So here's my number line. First one, x is less than 3. I'll put an open circle on 3, and all of the numbers less than 3 are to the left of 3. Second one says x is greater or equal to 5. So here's my 5 is greater or equal to 5. So I'm including 5, closed circle. The numbers greater than 5 are to the right of 5. And don't forget, here you still need to write the final answer. Make your final graph. Remember, or means union. We need to remember and means intersection, or means union. So for the final answer, we'll take our two graphs and combine them into one line. So here's my first graph, the line for my first graph. Open circle on 3. As you see, between 3 and 5, I do not have any lines. There's no answers there, so I skip that part. But past 5, I still have answers, so I bring all of those down. So my final answer is all of the numbers less than 3 and all of the numbers greater than or including 5. Moving on to problem number 11. Here we move on to absolute value. Number 11 and 12 are very similar, and they're both absolute value equations. So we have an equal sign. So remember, the first step we do whenever we have absolute value, it doesn't matter if it's absolute value equations or inequalities, we have to isolate the absolute value. By isolating, I mean take your absolute value bars and everything inside and get them by themselves on their side of the equal sign or inequality sign. So here's my equal sign. On the left side of the equal sign, I have only the absolute value expression, so it's already isolated. So number 1, isolate the absolute value expression. After you isolate it, then you can split into 2. So here you have to split your absolute value into 2. How I do this is take what's inside of my absolute value, which is x minus 3. And for the first equation, I'll equal it to the positive value, so to 2, and then to the negative value, negative 2. Now I get my two separate equations, and I can move on to solving. Solve. I need x by itself, so I need to add a 3 on both sides. 3 goes away, and I get x equals 5. And for the second one, I have to also add a 3 on both sides. My 3 goes away, and x equals positive 1. The problem also says graph, so make sure you graph these two solutions. Here's my number line. I got 1 and 5. You only have two solutions here, so the way I graph them, I just put a dot on the two solutions. Here I do not need any arrows, because remember, arrows, I only use those in graphing inequalities. These are equations, so I do not need arrows. I have the equal sign. There's no inequality. Number 12 is very similar. Step number 1, isolate the absolute value. Well, my absolute value is already isolated. It's by itself on the left side of the equal sign. So I can move on to the next step and split this into two separate equations. So I take what's inside of my absolute value and I equal it first to the positive 14 value and the second time to the negative 14 value. So once to the positive, once to the negative. And now I can move on to solving these. Again, I need x by itself, so the first thing I get rid of is that constant. So I subtract the 2 on both sides and get 2x equals 12. Again, I still need x by itself, so now I can divide by 2 on both sides. The 2 goes away, and I get x equals 6. If I look at my second equation, same idea, I need x by itself, so I'm subtracting a 2 on both sides. The 2 goes away, and I get 2x equals negative 16. I still need x by itself, so I'm dividing by a 2, and I get x equals negative 8. By the way, here I do not need a connecting word between the two, because those connecting words and or are only used for inequalities, compound inequalities. These are not inequalities, so I do not need a word to connect them with. So when I graph them again, because they're not inequalities, all I have to do is put a circle or a dot around my two values. So here's my 6. I'll put a dot on my 6 and negative 8 somewhere here. So I'll put a dot on negative 8. Problem 13 is a very similar idea to what we just did, but now we have, instead of the equal sign, an inequality. Less or equal than. I still follow very similar steps. Step number 1, isolate your absolute value. My absolute value is already isolated. It's by itself on the left side of the inequality sign. So now I can move on to splitting this into 2. Just like we did before, we take what's inside of the absolute value, which is 2x plus 10. And for the first inequality, I'll keep it the way it is in my original problem. So 2x plus 10 less or equal than 8. For my second inequality, I'll flip that inequality sign, make it greater or equal to, and I'm making that 8 into a negative 8. So you notice it's almost identical to what we did in number 12 up here. Here we also split the inequality into 2. Once we equaled it to the positive value, once to the negative value. Here we also have the positive value on the left, negative on the right, but the difference is that we have to flip the inequality sign for the negative value. And now I can move on to solving these independently. So I'm subtracting a 10 on both sides to get rid of that 10, the constant. So I get 2x less or equal than negative 2. Next thing I have to get rid of is 2, so I'm dividing on both sides by 2, and I get x is less or equal than negative 1. And I'm done solving the first one. The second one, again, I have to get rid of that 10, so I'm doing the inverse operation. So I'm subtracting a 10 on both sides to get 2x greater or equal than negative 18. Next thing I have to do is divide by 2 to get rid of 2, and x is greater or equal to negative 9, and I'm done solving the next one. Now you see I've obtained two inequalities. So remember, whenever you have two inequalities, I need a word in between. Remember, I need either and or. This was part of our first page of definitions. This was number 5. So there's a reason why I give you guys these definitions for the test, because you actually use them throughout the test. So here, in order to know what word to use, I need to remember the acronym, which is GOAL. G stands for greater than symbols. O stands for or. A stands for and. L stands for less than symbols. So here, if I look at my original problem, I had a less than symbol, which tells me I need to use the word and. Now that I know the word, I can move on to graphing these. So remember, you graph them both on the same number line. So the first one says x is less or equal to -1. So I'll have a closed circle on -1. All the numbers less than -1 are to the left. Second inequality says x is greater or equal to -9. So I'll put a closed circle on -9. And all the numbers greater or equal to -9 are to the right of it. And here again, don't forget to still graph your final answer, which combines the answers for your two inequalities. If the combining word is and means intersection, again, you need to remember and means intersection or means union. So I look, where do my two lines intersect or overlap? And that's between -9, including -9, all the way to -1, including -1. And that's my final answer. Problem number 14 is very similar to number 13. The only extra steps you need to take are the steps needed to isolate your absolute value, because in this case it is not isolated. So step number 1, isolate your absolute value expression. That means on the left side of my inequality sign, I want to have only this absolute value. I want to get rid of the 2 and the 4. As always, we get rid of that constant first, so we do -4 on both sides. The 4 goes away, and I get 2 absolute value of 6x minus 5 is greater or equal to 50. I still need to get rid of 2. So I'm dividing by 2 on both sides. Why dividing? Because between 2 and my absolute value, I have multiplication. And I need to undo that. So I do the opposite, which is division. My 2 goes away, and I have 6x minus 5 in absolute value, greater or equal to 25. At this point, I have my absolute value isolated, and I can move on to splitting this into 2. From this step on, it's very similar to problem number 13. So let's split this into 2. Remember, you take what's inside of your absolute value, which is 6x minus 5. For the first inequality, I'll keep everything else the same, greater or equal to 25. And for the second one, I flip the inequality sign, and I put a negative in front of my value, so -25. Now that it's split into 2, I can continue by solving each one. I need x by itself, so I need to add a 5 on both sides, and I get 6x greater or equal to 30. So I'll rewrite it here to the right. 6x greater or equal to 30. I still need x by itself, so I need to divide both sides by 6. 6 goes away, and I have x is greater or equal to 5. So I'm done solving that first inequality. Now let's look at the second one. I want to add a 5 as well to get rid of that 5. And I get 6x less or equal to negative 20. I'll rewrite it up here, 6x less or equal to negative 20. I need to get rid of 6, so I'm dividing both sides by 6 again, and I get x is less or equal to negative 3.3. In this case, I didn't have to flip the inequality sign because I divided by a positive. So now I have my two inequalities solved. I just need that connecting word in between. So remember, whenever I have two inequalities together, I do need a word to connect them by. So let's think of our acronym again. The acronym was GOAL. G stands for greater than symbols, O stands for or, A stands for and, L stands for less. In our original problem, we had the symbol greater or equal to, so that's a greater symbol. That means we use the word or. And you can also look on your first page of definitions. It's on page 13 at the top. So now that we know the word, we can go ahead and graph these. So here's my number line. First one, x is greater or equal to 5. So I can put a closed circle on 5. And the numbers greater than 5 go to the right of 5. Second inequality says x is less or equal than negative 3.3. So I'll put a closed circle on negative 3.3. Numbers less than negative 3.3 are to the left. And as always, whenever we have a compound inequality, we need to graph the final answer. So remember again, OR stands for union. So I'm taking my two lines and putting them together into one. So my first one goes from the left all the way to negative 3.3. There's no answer lines in between. Then I bring down that second line, which is from positive 5 all the way to the right. So my final answer looks like a combination of the two lines put together. And now let's look at the last two problems. So these are problems 15 and 16. These will be exactly as your real test, and they're meant to get you accustomed to ACT questions. So this is how ACT questions look like. They have multiple answers. And if we look at number 15, the question is, how many solutions is it possible to have on an absolute value equation? So A says 0. Can we have 0 solutions? Yes, we can. Let's look at the following example. Absolute value of x equals negative 1. Is this possible? Can absolute value ever equal a negative? This is impossible. Remember, absolute value is always positive. It is distance. Distance is always positive. So I cannot say that the distance from 0 is negative 1. I can only say the distance from 0 is a positive number. It doesn't matter. Remember, if I have the number line, here's my 0. Absolute value of x tells me I'm looking for a number who's negative 1 units away from 0. Can I have negative 1 units away from 0? No. Either I go left 1 unit or right 1 unit. I'm still going a positive amount of units to the left or right. So this would be 0 answers or no answer, right? No answer. So this would be no solution, which is the same as saying 0 solution. So this is possible. Is it possible to have one solution? So let's take absolute value of x equals 0. So if I split this into 2, I take what's inside my absolute value, once equal it to the positive, once to the negative. But can I have negative 0? Negative 0 is just 0. So both of my answers are the same. So I only have one answer, x equals 0. So yes, it is possible to have only one answer. Is it possible to have two answers? Well, yes, most of the problems we've done so far, you've had two answers. Absolute value of x equals 2 is one example. I take what's inside my absolute value, which is x, and I equal it once to the positive 2, once to the negative 2. So those are my two answers. So yes, two answers is possible and highly likely. So I'll say my final answer for this question is all of the above, all of the above. And the last one, number 16, for what value of x is the statement false? Is the statement false? If you don't know on your ACT how to solve something like this, you can go ahead and plug in the values and see which one gives you a false statement. All right? So let's take the first one. The first one is -2. So I'm just plug it in. I have 2 times -2 squared less than, parentheses, 2 times, instead of x, I'll plug in -2, everything squared. What is -2 squared? Well, -2 squared is 4. So I get 2 times 4 less than, first I solve the parentheses. What's 2 times -2? Well, that's -4. So I get -4 squared. Remember, order of operation, parentheses first. Now I can go ahead and multiply here. 2 times 4 gives me 8, less than -4 squared gives me 16. Is this false? No, this is true. 8 is indeed less than 16. So E is not false. I'm looking, remember, I look for a false statement. Let's look at F. Next one says 0, so I plug in 2 times 0 squared less than, parentheses, 2 times 0, everything squared. What is 0 squared? Well, 0 squared is just 0, so I get 2 times 0 less than. Solve the parentheses first. 2 times 0 gives me 0 squared. Now I can multiply here. 2 times 0 gives me 0, less than 0 squared gives me, again, 0. Is this true or false? Is 0 less than 0? Well, this is false because 0 equals 0. 0 is not less than 0. So I found my false statement. So the correct answer for this ACT question is F, which is 0. All right, hope this video helped. Please try to go over these problems again for the test. And let's hope to get a high grade on the test. Thank you so much. Have a nice day.